Hi, in this video, I'm going to be demonstrating the 2D slot milling toolpath in Mastercam. So I'll be sticking to utilizing the outline for those 4-inch by 2-inch by 1-inch blocks. So using the outside geometry of that rectangle, and then in the middle, placing an ob round, so a rectangular ob round in the middle. And then doing a slot mill tool path for that to cut the ob round out. So again, just want to stick to the very basics of the tool path and using very simple example parts here, and particularly ones that we will be using in class when we actually go to mill things on the CNC. So that's the once again the reason for sticking with the simplistic examples, so that you guys can get the basics of this without a lot of the frills. So at any rate, let me go ahead and start by drawing my rectangle to represent the outside of the part, the outside of the finished part. So I'm going to use this rectangle function. I do want to anchor the center to the origin. So I'm going to go ahead and do that. And then I'm going to change this width to 4 and the height to 2. And select OK. And then I'm going to go back into this rectangle. So, just so you can see that in the rectangle function here on the toolbar, there is a small drop down, and it has several things in the list. But what I'm going to be using now is this rectangular shapes one. So when I left click on that, it opens up this rectangular shapes dialog box. What I'm going to use is the ob round. So I have the ob round that's already selected here. So the radio button is already enabled. I'm also going to be using the base point method. So in other words, I'm going to just select the base point, much like I did with the outside of this rectangle. And I'm also going to make the origin the center of the ob round at the origin, so to kind of coincide out here, so that I can anchor this to the center, so that it will be centered inside of this outside rectangle. I'm going to make sure that these, you can see that these are already set to 3 and 1, which is the width and the height that I want. But I'm actually going to retype these in, because what I noticed before is if I didn't, then certain things didn't happen the way I had thought they would. And so I want to go ahead and do that. So I'm going to go ahead and select this base point. And when I select the base point, what happens then, it automatically puts my ob round onto the screen. So before, what I noticed was that even though I had the 3 and the 1 in there, I went out to select that point, that origin point, and it didn't automatically put the ob round in as it had done previously. So I figured out that I had to make sure that I put the numbers back in again. So at any rate, you'll see what's on the screen now. It also comes with this, this sort of handle that you can use to rotate this thing around and slide it and move it around and things like that, to make angles with it or whatever it might be. In this case, I don't need to do anything else with this. So what I'm only doing this one ob round right in the center here, mainly to show you how to use this particular shape, because it is a pretty common shape in different mechanical parts. So I will select OK to this. And so now, I've got my overall part representation here, the outside of the finished part, as well as the ob round inside of here. So the one more thing that I want to show you that I don't think I've spent much time with is the drafting. And specifically putting in dimensions. So I had entered, a width of 3 and a height of 1. So in Mastercam, just to kind of show you what does that mean in terms of an ob round, because there are better ways to dimension ob rounds, if you're doing an engineering drawing. But again, here the purpose is more to use this as my place to do a slot mill, because this is a very familiar shape for slots in machining. So let me just go ahead though and show you what the 3x1 actually means to us. So inside of the drafting tab, there's actually this whole dimension group that's here. So I'm going to select this horizontal one. And I'm just going to simply click on these because I want to show you so that the center of this radius and then the center of this radius as well, just so that I can show you what this horizontal dimension is. So this is the 3 that we had entered in as our width. And then of course, the 1 as our height. So what I'm going to do now is I'm going to get out of this and I'm going to use in this drop down, in this dimension drop down, I'm going to use the vertical and I will select here and select here. And so now you can see, so this is the 1 inch height then that we selected for the brown. So these are the dimensions. I don't really need the dimensions in here. So, but I just kind of wanted to show you, give you a very brief introduction to adding dimensions here in Mastercam. Most of the time in class, if you're doing anything that's more complex than this, most likely you guys will be using SolidWorks because that's what you use in some of your other classes, some of your other engineering graphics classes. So, so again, that's another reason I try to keep these to some simple representations of geometry here. So let me just cancel out this and actually we don't need these dimensions in here. So I'm just going to select on them and just hit the delete button on my keyboard and get rid of them. So let me take this now and move it so that our origin for, so our origin on the screen is here. I want to take and make my lower left corner of my part at that origin as well. So right now it's in the center, but that's not what I want because remember when I set my stock up for use on the milling machine, I like to try to keep those 2 points in the same spot. So let me take use the transform tab here, and in this position group there is a move to origin. So this is a kind of a review of this function. It tells me to select the point to translate from, and I'm just going to select this lower left corner, and that just moves the whole all of the geometry up here. We get this purple color, and again, the way to take care of that if you want to get back to your original geometry color is to go to this home tab and then select clear colors, and it will bring you back to this. So let me also just save this for now. So I do like to save as early as I can typically, and I encourage students to save early because you never know when you're going to get some sort of crash with the license server or whatever it might be, particularly now while we're in this remote teaching and learning setting. So do save early and keep saving often. So I will do a file save as here, and I will just browse to my class prep folder, and I'll just call this slot 1 and just click the save button. So now I'm actually ready to get my machine set up and do my stock setup and then go ahead and do my one tool path. So I'm really only doing just one tool path for this, which is going to be the slot mill. So let me select my machine. So as you guys will find from watching the rest of this video series, at this point now, this upfront stuff, including the machine setting and then the stock setup, gets to be fairly repetitive, and really would get to be fairly repetitive even if you were doing different shapes and things like that. So I'm going to select my mill, which is this generic Haas 3X mill. And once it opens up over here in the Toolpath Manager, I will go ahead and open the properties up. And in the tool settings, I will select the warrant of duplicate tool numbers and also each of these. So these three, the 4 check boxes in the advanced options. And then I'm going over to my stock setup, and I will select enable the display on the screen, enable the fit screen and the wireframe, which I believe are both defaults. I will change this origin to match what I have over here in my graphics area. And then I will use this all entities to go ahead and fill in at least the Y and the X dimensions. And then, of course, my stock part is approximately 1 inch. So I'm going to enter that in as well. So I will select the OK, and then I will go up here to my toolpaths. And so once again, just as a reminder, what we're trying to stick with are all of the 2D toolpaths. So in this case, I don't see the slot mill here. So what I need to do is just expand this gallery out and look for the slot mill. So in this case, here's the slot mill, and you can see that's, this oblong shape is what they even have as the little symbol. So we will open up that. And what I'm going to do is I'm actually going to use the window selection for this. So the chaining method that I'm going to use, so when this opens up, you'll see that I get this, the wireframe chaining. I've got the window selected here, and it tells me to sketch a window to select the entities. So because I have this window one selected, all I need to do is just left click and drag, and it will drag a window out. So I left click and hold and drag, and then I left click again. And what that does is that then selects that entire area, but then it also then tells me to sketch the approximate start point. So I don't really need to sketch anything necessarily. I just need to select on a point. So what I typically do is just go and look for a point that this will snap to. And so I did that. And I'll keep this arrow direction this way. It doesn't really matter too much to us on this. So I will just keep this, but if you wanted to change it, you can change the arrow direction simply by doing this. So down here in this, in the wireframe chaining dialog box, there is this reverse arrow that you can use to change that direction. So I'm going to select OK, and that brings me into this 2D Toolpaths slot mill. And so I'm going to now go down and select my tool. So in this case, the tool that I'm going to select is actually the 1/2 inch flat end mill again. So in order to get to that, I will select the tool filter, and I have this flat end mill enabled, and I've got this equal to 1/2 inch over here in tool diameter. And when I select OK and go back into the tool library, and I left click on the tool that's in there and select OK, and I'm going to change these tools to match the tool numbers on our tool list. So the tool list that we have for the tools that are always loaded on the CNC mill has the at campus, has the 1/2 inch flat end mill being tool number 6. So again, when I enter that in and I hit the enter button, what should happen and what you need to make sure happens is that the tool number, the length offset, and the diameter offset all change to tool number 6. So I'm also going to go down here and change the feed rates, the spindle speed, and the plunge rate as well. So I'm going to go to a 20 inches per minute and a 2,500 RPM spindle speed. And I will enable this rapid retract if it isn't already enabled, and also change the plunge rate to 20 inches per minute as well. And I'll just add in a comment here to, to slot mill part. So I'm done in here. So now I'm going to move down to cut parameters. And inside of the cut parameters, I'm going to keep the compensation type set to computer and the compensation direction set to left. I'll leave the tip comp alone. But the last thing that I'm going to do here is I'm all in this page, I'm going to take the stock to leave on walls and the stock to leave on floors down to 0. So I'm not too concerned about finishing passes and things like that and having to come back in here and take more material out. I'll just go ahead and do everything, the roughing and finishing, and clean out the entire slot all in one tool path. So I'm going to go down now also to the rough finish, and I'll leave this the ramp entry enabled, and all of the other things enabled here in terms of the defaults, and including if the number of finishing passes, I'm going to just set that to 1, just in the event that is not set currently. So I'm also going to go down into the depth cuts, and I'm going to enable the depth cuts because ultimately I'm going to make this depth go to a negative 0.8. So I'm going to make my max rough step here 0.2. So, and again, when we enter the max rough step, it's not like putting the max milling depth in the linking parameters. We don't have to make that a negative number. So in this case, this is sort of, you can almost think of this as an absolute value, but this is just the distance that the maximum rough step that this is going to take with the depth cuts. So I don't need breakthrough because I'm not breaking through the material. So if you think about it, what I'm going to do is take this down to a depth of 0.8. That'll be my maximum milling depth. The part thickness is 1 inch, so that certainly will not break through. So I will disable the breakthrough. And now I'm down here at my linking parameters. So I will enable, just as I have done in past videos, I'll enable this clearance, and using the clearance only at the start and the end of the operation, and also enable all of the absolute radio buttons. And I'll enter in here my final milling depth. So the final milling depth that I want to use here is a negative 0.8. So I'll just enter in negative 0.8, hit enter on the keyboard, and then go ahead and select OK. And you can see, so I'll change this to an isometric view. You can see here is my tool path, and you can see 1, 2, 3, 4. So what's happening here is because we entered in the negative 0.8 as our final milling depth, and we made our max rough step for our depth cuts be 0.2. It's divided up into 4 equal segments. So what I'll do is go ahead and run the simulation here. So once it comes up, I'll just keep it in this isometric view. I can kind of step through this, and you can see what's happening here is it's cutting the slot away. So anyway, once again, this is yet another toolpath that you can add to your arsenal of 2D toolpaths that you can use in Mastercam for the class or for other purposes if you're watching this video, certainly outside of the class that I would typically teach. So hopefully this was helpful to you, and hope it was a much shorter video than some of the other ones, but this is a pretty simple toolpath, and but a useful one nonetheless. So anyway, till the next video, I will see you later. Take care.